and welcome to another 5-minute video for the Level 3 Technical Certificate. In this video we're going to talk about the chemical composition of fibres. So there are 5 groups of components within a fibre or within a tree. Cellulose, that's the bit that all the paper makers want, that's what makes the sheet of paper. Hemi Cellulose, these are molecules, as you might guess, a little like cellulose, but they're actually a lot smaller and more soluble, that contribute to the strength of the sheet. Lignin, this is a very hydrophobic material that ultimately turns to coal if you bury the trees for a few million years. Extractives, very tiny proportion of the trees actually extractives, only a percent or two, but they're the things responsible for the charge on the fibre. And then finally, ash. So here we can see cellulose. We've seen cellulose before. Cellulose is actually a polymer of glucose. So there you can see individual glucose molecules put together oppositely. That makes cellulose. Had they all been in the same orientation, we would have had starch. What can we say about it? They follow the hydroxyl groups. This is the thing that bonds one fibre to another. This is what gives us the hydrogen bonding that makes the sheet stick together. So, important points are, it's a long chain polymer of glucose and it's insoluble. If we move along now to the second component, we talked about hemicellulose. Whereas cellulose is just hundreds or thousands of glucose molecules strung together, hemicellulose is actually a mixture of different types of sugar. Don't worry about these, you'd never be asked to remember anything here. This is just to demonstrate there are lots of different types of sugar. So hemicellulose usually consists of 2 or 3 of any of these sugars coming together to form a molecule. These molecules are much shorter than cellulose and they're also soluble. But the important thing to remember is that they're all full of these OH groups, and that's what we need, the OH groups, for the hydrogen bonding. So hemicellulose is short and it's soluble. Those are the 2 important characteristics that you need to remember. That's all you need to remember. And it's usually a mixture of different sugars. Okay, moving on now to lignin. Lignin is an incredibly complex molecule. They say that there's no 2 bits of lignin alike anywhere on Earth. So it's a very complicated molecule. You can dry it down, you can produce lignosulfonates that's used as dispersants. It's used in the drilling industry. And the thing about lignin is it's a hugely complex molecule. It's hydrophobic, meaning it's very water repellent. So if you leave the lignin in the fibres, you're very limited to what you can do. You produce then what we call a mechanical fibre, and that will have good stiffness properties, but not very good for strength. And it helps to give the structural strength to trees. Next component, of course, is the ash. When you burn wood, what's happened is the tree has, through its lifetime, it's taken up a lot of minerals out of the soil. When you burn it, you're essentially oxidising them, and particular metals like potassium and sodium you convert into their oxides. So you'll get potassium oxide, sodium oxide, very high alkalinity ash. Then of course those will absorb moisture and they will turn into potassium hydroxide and sodium hydroxide. And then we have the extractives. Now, as I said before, just a very small proportion is extractives, and this is just a small sample of those. There are actually thousands of different molecules, and these thousands of different molecules in the extractives will give the odour to a tree, they'll give the colour to the tree, and they'll also provide biological protection. The important thing to note is all of these contain these carboxyl groups, this COOH group, and this is really important because these carboxyl groups can ionise. Above pH 7 they will ionise, the H will float off as a H plus as a proton. The bulk of this ending in C minus will be attached to the fibre, and this is where the negative charge on fibres comes from. So it's responsible for the charge on the fibre, the carboxyl group from the extractives. So, quick summary. 5 components. There are cellulose, hemicellulose and lignin. These are the things that the paper maker are really interested in. The cellulose for the actual weight of the sheet, the substance of the sheet, hemicellulose to provide extra bonding to give you a good strong sheet, and lignin. If you leave the lignin in, you'll have a very stiff sheet. If you take the lignin out, you can modify it with refining and you'll have a very white, flexible sheet. Then there's the extractives and ash. We can't really do very much about those, and they don't contribute too much to paper making. And finally, it's the extractives that are responsible for the charge on the fibre. Okay, well, thank you for listening to this short video, and please feel free to follow us on any